Skipping now to page 207, problem number 3, we're going to look at what happens over time as we continue to add money into our account. So looking at this table that's given in the book, we have the start time where you deposit the money so you don't earn any interest, and you'll have $600 in the account. Well, then after the first year, we calculated before that 5% of that $600 was $30 added into your account. So you will earn $30 and the account balance will be $630. But then in year 2, because this is simple interest, we're going to give you another $30 on that initial $600. In other words, the amount of interest you earn is fixed throughout the lifetime of your investment. So we would take the initial $30 that had been given to you after the first year, we add to it another $30 that you're now being given to you in the second year, giving us $60, and your account balance is now $660. If we continue this out for another, let's say 3, 4, 5 years, each year we're going to add $30 to the previous amount of interest earned. So we'd have $90 after year 3, and our account balance would be $690. After year 4, we'd add another $30 to the 90, leaving us with $120, and our account balance would now be $720. And then at the end of the 5th year, we'd add another $30 to that 120. We'd now have earned a total of $150 interest, and our account balance would be $750. Question 4 is a fantastic question because it's asking us to look at the pattern, what's happening. So when we look at this table, we see that this is a fixed amount of money that's added each time. And if we recall from Unit 2, when we add a constant amount, that's what is called a linear relationship. So this simple interest is a linear relationship. And in fact, the change, that rate of change, in this case, which, because it's linear, is the slope, is equal to exactly $30. And our initial value, or the value at time 0, or the y-intercept, is the amount of money we invested at the very beginning of this, which happened to be $600. We called that value B. If you recall, we wrote it as 0, 600. So not only can we say this is a linear relationship, we can write an equation to model it. And we could write it like this: y equals $30 times the number of years we invested this money for, plus the initial amount we invested. So for example, if we said, well, what's the account balance? Spell it right, of course. What's the balance after, why not 30 years? We would simply note, hey, this is x equals 30. Plug that bad boy into our equation, and we'll get the account balance. We won't have to go through this whole table thing. We can just say we're going to get 30 payments of $30 added to our $600. And this is, let's see, 30 times 30 is 900 plus our 600. And voila, after 30 years, our account balance would be a solid $1,500. We might be able to pay for 1 month's rent with that money. Turns out in the financial world, we're quite interested in the language of all this. And so this table becomes quite important because these are the types of words you're going to see used in formulas and also the letters used for them. So when we talk about interest, that's going to be a fixed amount of money. It's either going to be the fee charged, like if you're using a credit card or getting a mortgage or a car loan, we call that I, and it's a specific amount of money. We'll label P as the principal, and this is the amount of money you borrow or invest. And then R is the rate, which is really the interest rate. So this is typically a percent that we convert to a decimal. Don't confuse the interest rate with the interest. Interest is a fixed amount of money, and the interest rate is a percentage. And then, of course, we'll have time. We typically talk about years, but when we get into car loans, we're going to be doing that monthly. And finally, we call this thing the future value. We label it A. That's the account balance at the end of the loan or at the end of the investment. So it's essentially how much money do you have after this specific amount of time. So on page 208, we now encounter an attempt to create a general formula for how to calculate simple interest. So if you recall what we started with, we had this tax refund of $600 that we invested, and we will call that now our principal. And we had an interest rate, or as the book calls it, a rate, equal to 5%. So our symbol for that is no longer the word rate. We like to save on ink. We write R, and of course we already know that 5% is 0.05 as a decimal. When we calculated the interest, we took the 600 and we multiplied it times the 0.05, and we got the amount of interest. That was $30. Well, what if we want to invest a different value, a different amount, at a different interest rate? How could we generalize this formula? Well, that's the beautiful power of letters. So instead of saying I equals the $600, we're now going to say I equals whatever principal amount we want to invest, and we're going to multiply that times whatever the rate is that we receive on that investment. This would give us the amount after 1 year. So we'll say value after 1 year. But what if we wanted to know the amount after, let's say T years? Well, instead of using the 1, replace that 1 with a T, and we now have a simple interest formula. Now be careful. This is not the value of the account balance. So it's not the amount of money that's in your account. It's the amount of interest you earn over a particular period of time. We can use this formula to answer question 3. It says, well, let's use our formula. We kind of already did this before when we noted there was a linear relationship. In question 3, we're asked to calculate the amount of interest we would earn in 30 years. Well, if we just use this simple formula, our P was $600, our interest rate was 0.05 or 5%, and we're now going to calculate this for a 30-year period. So we would do 0.05 times 60, that's $30 per 1 year, and then multiply that times 30 years. Note the years cancel because this is year divided by year, and we get what we already noted before, that you would earn $900 in interest. Again, recognize this is not the account balance. This is the amount of interest that would be deposited into your account after that 30 years. If we want the account balance, we simply take the interest we earned here, which was 900, and add to it the principal, which was 600. So in general, if we want to use the letters that were given before, the account balance, which is represented by A, is equal to our $900 in interest we earned, plus our $600 in principal that we initially invested, and we get that total that I already showed you using the linear formula, $1,500. But what if, of course, we have a different amount of invested, so we earn a different amount of interest because maybe we have a different interest rate, and we invested a different initial amount? How could we generalize this formula? Well, just take the A, and instead of adding together the numbers, let's use these letters that can represent any number we want. This would be the interest plus the principal equals the account balance. Recall from above, we already know that I equals some principal times some rate times some specific time. We're going to take this and replace it in this formula. And then if we just wanted to directly calculate the final account balance after some particular amount of time, we would take the principal, multiply it times the rate, times the time, and add to it the initial principal. So we'll call this formula 1, we'll call this formula 2. Either of these formulas work perfectly. So in general, we really have 3 different formulas here. 2 identical formulas, 1 and 2, for the account balance, and 1 formula that calculates just the amount of interest earned.